Lesson 2. Today we're talking about multiplying and dividing whole numbers and money, and we're working with fact families, the second part. Now the first problem that we have is to find the cost of 2 dozen pencils at 35 cents each. So if we want to solve this problem, the first thing we need to know how many 2 dozen would be. How many is 2 dozen? Say it out loud. Well, 1 dozen is 12, so 2 dozen must be 24. So if we have 24 pencils at 35 cents each, well, we're going to have to multiply. We're going to say 24 times 0.35. Now notice when we multiply, it doesn't matter if we line up the place value, because of course the 4 is the 1s, which would map to the 0, and the 3 would map over here. We don't need to line it up. All we do is multiply across. So 5 times 4 is 20. We've got a 0. Add our 2 on top. 5 times 2 is 10, plus 2 more gives us 12. We've got a placeholder 0. We've got 3 times 4, that's 12. We carry the 1 this time. 2 times 3 is 6, plus 1 more is 7. So now we find the sum. We add these together. We're going to get a 0, a 4, and an 8. We get 840. But if you think about 2 dozen pencils costing 35 cents each, costing $840, that would be a bit ridiculous. I don't think I would pay $840 for 2 dozen pencils, and I hope you wouldn't either. We need to move the decimal point over twice to get it out of our numbers. 1, 2. So now we need to bring it back within our answer. 1, 2. We take it out, we bring it back. So we've got $8.40 because we have to move the decimal the same amount of times back in our answer as we moved it out of the numbers we're working with. So we've got an answer of $8.40. That seems a little bit more reasonable to pay $8.40 for 24 pencils rather than $840. Make sure you've got this copied down in your notes. Alright, next problem. We're going to multiply 800 times 474. Now when we do this problem, we can line it up vertically, 474. And this one, we're going to line up so we've got 800 like this. And this is very nice because it allows us just to drop our 2 zeros straight down. We're multiplying, so now when we've dropped our 2 zeros straight down like that, this only works with a number that's ending with zeros. It could be 1 0, 2 zeros, or more. Now we multiply the 8 times the 4, the 8 times the 7, and the 8 times the 4 again. So 8 times 4 is 32. We're going to carry the 3. 8 times 7, 56, plus 3 more is 59. Carry the 5. 8 times 4 is 32 again, plus 5 more gives us 37. So we've got our answer. Our answer is going to have to be 379,200. Make sure you've got this copied down in your notes. Now we've got some key vocabulary today. Commutative property, we talked about that in lesson 1 for addition. We can also use that for multiplication. It's the same definition. Order does not matter. Now this time though, when we look at the commutative property for multiplication, we're going to work with multiplication problems. Order doesn't matter. So let's say 7 times 3. 7 times 3 is equal to 21. And 3 times 7 is also equal to 21. So we can see that it doesn't matter which order we take what we're multiplying, we still get the same answer. Now when we're talking about multiplication like this, the two numbers that we multiply are called the factors. And the factors multiplied together will equal the answer, and the answer to a multiplication problem is called the product. P-R-O-D, whoops, that didn't come out very well, so let's back up a little bit. We'll erase. We've got the product here is 21. And the product is the answer to any multiplication problem. We'll just scribble that piece out. Okay, so 3 would be a factor, 7 is a factor, 21 is a factor. Now our second definition is about the identity property in multiplication. And remember that identity property just means you keep what it was to begin with. So the only way that we could have that is to multiply by 1. So if we had 7 times 1, that's equal to 7. we had 19 times 1, that's equal to 19. So any number multiplied by 1 keeps its own identity. It stays the same. Now the zero property of multiplication, our last key vocabulary word for now, it is when you multiply by 0, it's always equal to 0, the zero property. So let's say we have 3 times 0. Well, 3 times nothing is nothing. So 3 times 0 is equal to 0. Let's say we have 21 times 0 must be equal to 0. So here are our definitions. For the commutative property we have some words, but for each other ones we just have examples. Make sure you've got those examples written down under each of these vocabulary words. Alright, now we're going to divide. We've got 3,456 divided by 7. 3,456 in the box. 7's out of the box. And we're going to go ahead and we're going to divide. 7 goes into 3 0 times. We could put a 0 there, but we don't have to. 7 is going to go into 34. Well, 7 times 4 is 28. 7 times 5 is 35. That would be too big. So now we're going to subtract 34 minus 28. Well, we could borrow and regroup. We've got a 2, we've got a 14. 14 minus 8, that's 6. Now we're going to bring down our 5. 7 is going to go into 65 how many times? Hopefully you said 9. 9 times 7, that's 63. We're going to subtract, we've got 2, and we're going to bring down the 6. We've got 26. 7 is going to go into 26 3 times. We get 21. So we've got 5 left over. So we have an answer of 493, remainder 5. In this lesson, we're going to report all of our answers for division problems that have remainders with remainders. If you know how to turn this into a decimal or a mixed number, that's fantastic. But for now, we're going to go ahead and we're going to leave it as a remainder. If you know how to do short division, you're welcome to do that as well, as long as you show your work. If not, please use long division. Now, whenever we have a division problem, and I'm going to rewrite this one, we've got 3,456 divided by 7, and we've got our answer right over here. We have some vocabulary words that we need to know. This number in the box, it's great to say a number is in the box, but we want to be more specific. This is called the dividend, D-I-V-I-D-E-N-D. The 7, the number out of the box, you can call it that, but you need a technical term as well. It's called our divisor, and that's a D-I-V-I-S-O-R. And our answer to any division problem is called the quotient, Q-U-O-T-I-E-N-T. Okay, so when we have a dividend of 3,456, a divisor of 7, we get a quotient of 493, remainder 5. All right. Rearrange the numbers in this multiplication fact to form another multiplication fact and 2 division facts. So first, we check, we make sure this is true. 5 times 12 equals 60. Yes, that is correct. Then we're going to rearrange our factors. So the first one is going to be 12 times 5 is equal to 60. Commutative property, order doesn't matter in multiplication. So we've got 12 times 5 equals 60. That's our other multiplication fact. And now we need 2 division facts. So we're going to say 60 divided by 5 first. 60 divided by 5, we can go through the math. We got 1 time, that's a 5. We've got 10 left over. After we subtract, it's going to go in 2 times. Ooh, perfect. 60 divided by 5 is equal to 12 because we have nothing left. So our second division fact, or our first division fact, our next one in our fact family, is going to be 60 divided by 5 is equal to 12. And I bet you can guess what's next. 60 divided by 12 is equal to 5. And we've got our whole fact family. We've got all the problems that we need written out. Alright, our lesson practice for next class is going to be on page 10. Please make sure you've got all your notes done. If you have a question, write it down. Otherwise, I will see you next time.